Everything we're doing in this unit is shifting parent functions. And so we want to get really good at just recognizing the shape of a function based on the equation that we're given. So just like yesterday, we have equations today that have h's and k's. And yesterday, what did the h do? Moved it left or right. So it's a horizontal shift, H for horizontal. So this is going to be a shift left or right, horizontally. And the reason that is because it's inside the function and it's with x. So because it's together with the x, it's moving in the x direction, and our x-axis goes left to right. What does the k in all of these functions do? It moves it in the y direction. It moves it up and down. So it's a shift vertically. Whose music am I hearing? Someone's music is like ridiculous. All right. And then, so yesterday we talked about two parent functions. Yesterday we had the square root of x. Ladies and gentlemen, what did the square root of x look like? What shape was it? I gave you a word. Swoop. Yesterday it was the square root swoop. And so the square root function had this swoop shape. So we called it the swoop. Square root swoop. Very good. And we also talked about the cube root function. What was the cube root function's shape? The wave, the breaking wave. And so we had these three main dots here right along the center, three in a row. And we had this breaking wave shape for the cube root function. And those words, whether it's swoop or wave, are words that we create together as a sort of common understanding of things. So when you say those words, it puts a picture in your head. And that's really important. So today we have a couple of new functions that we want to understand as parent functions. And again, we want that basic shape. And that's what we want to know and understand. All of these functions today and yesterday we can put into our calculator. And it's really a good idea to make sure you know how to do that. But it's way faster to know the shape and shift it by hand. It takes a long time to put these in the calculator. So this first function says it's x being squared. So the base function is y equals x squared. Does anyone know what y equals x squared looks like? Well, if you didn't know, you could graph it in your calculator. There it is. Y equals x squared. And what's its shape? Parabola. Every single time. Its shape is a parabola. And it has a few main points. So we just want a couple main points to get going with. It passes through 0, 0, and 1, 1, and negative 1, 1. And again, if you wanted to know why, it's because of the XY chart. We plugged in values for x and square them, you will get the outputs that create this base function. So if we take negative 2 and square it, what do we get? What's negative 2 quantity squared? 4, that's right. So negative 2, 4. And positive 2, 4. And so we get this basic shape of a parabola. It is a U shape.
Wasn't it like 0, 0, and then 1, 1, and 2?
Yes.
For the square?
This is square root. This is the squaring function. They're different.
Oh.
Right? So this is a square root of x. This is x being squared. Those are very different. Okay? All right. This base function here is x to what power? X to the third power. So this is x to the third. Is this the same as what we did yesterday? No, it's different. All right, so it's a different shape. This graph, again, I could do an XY chart to figure out these base ordered pairs. Let's see, what is 2 to the third power? 8. So it actually has 2 and then 8. 1, 2, 3, 4, 5, 6, 7, 8. And again, that's a very large point, large number value, but it's good to, the first time, to understand the shape and direction this is going. If we plug in a 1, what's 1 cubed? 1. So 1, 1. 0 cubed is 0. Negative 1 cubed is negative 1. And then negative 2 cubed is negative 8. Negative 1, 2, 3, 4, 5, 6, 7, 8. Here. So this is the shape of the cubic function. So x cubed. I don't have a special name for this. This is the parabola. You can use your arms. That's the best thing. It's, you know, like touchdown. That's the shape. Go. Okay. So, but this one, I have no name for it. My pre-cal kids call it the stretchy S. Does it look like a stretchy S to you? I don't really know. Last period liked the slide. Do you see like a water slide? The one where you have to lay down and cross your arms and ankles, you know? It's like zoom. All right. It is an increasing function. It's going uphill from left to right. So maybe we'll just call it the slide. Whee! Definitely looks like a fun slide. Okay. What are these bars? Absolute value. And SOLUTE, absolute value. Guess what the shape of absolute value is? Absolute value V. Every single time. That's an easy one to remember, absolute value V. The absolute value function starts at 0, 0. It goes 1, 1, 2, 2, 3, 3. Negative 1 turns into a positive. Negative 2 turns into a positive 2. And so that's how we get this V shape. Okay. And you'll notice that the parabola and the absolute value V have these same 3 points. Negative 1, 1, 0, 0, and 1, 1. Are they the same shape? No, they're very different shape, and you have to do it properly. So the parabola is a nice rounded, smooth U, and the V is a pointed V. So the shape really, really matters. Okay? So we're going to call this the U or parabola shape. This is our slide, the going up slide. And this is our V shape, absolute value V. And then, of course, from yesterday, we have the swoop and the wave. And these are, I mean, words you're never going to hear another teacher use. It was just me and my lovely non-math way of teaching. But parabola is a math word. They probably just call this the cubic. Just lame. So. All right, let's try a few. So example 1, graph the core, then shift, identify domain and range. Graph the core. Oh, I use the word core. I use a different word every year. Base, parent, function. Graph the main one. Graph the basic shape. I don't know, whatever word you want to use. Then we're going to shift it just like we learned how to shift yesterday, which is kind of nice. So we have y equals, what are these symbols? Absolute value. So these are big absolute values. So since it's an absolute value bar, so what shape is this graph? Absolute value V. So that's what we're going to start with. 1, 2, 3, 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 5. Okay. So we're going to start with those basic 3 points. Where do those base 3 points start? What are the 3 points? 0, 0. What else? 1, 1, and negative 1, 1. So those are our main 3 points. And again, these are just for reference. This graph isn't really there. If you want to just use those 3 dots, that's fine. If you want to do a dotted graph, that's its original starting position. But now we're going to slide it around. How does x minus 2 move this base graph? Which direction does it go? Left or right? Right. Right 2 units. It's opposite of what it looks like. Why is that? What's going on? If you solve for x, that's exactly right. If we take all of that, x minus 2, and set it equal to 0 to solve for x, it's going to say, hey, we've got to add the 2. And that's where we get 2 units to the right. All right. So this is right 2 units. On the outside, it does what it looks like. So what does negative 4 look like? Down 4. So we're going to take 0, 0 and just count right 2 and down 1, 2, 3, 4. And then I can make my three dots from there and just draw my nice V shape. All right, so the actual graph is that pink graph. And so now looking at the pink graph, what do these arrows mean? Infinity. They go forever. They go to the right forever and they go up forever. This arrow goes to the left forever and it goes up forever. And that's important. Domain refers to the x-axis or x values. Range refers to the y-axis or y values that we get for our graph. It's alphabetical, in case you have trouble remembering that. X before y, domain before range, D before R. All right, it's alphabetical. So on the x-axis, when we're looking at this pink graph, how far to the left and how far to the right does those pink lines go? That was a really weird sentence. How far left and how far right? Infinity. Negative infinity to positive infinity, we use parentheses because we can't actually touch that. We just get close. On the y-axis, we want to know how low and how high does our graph go? What is the lowest y value? Right here, negative 4 is that lowest y value there. So negative 4 is the lowest. What's our highest y value? Yeah, it goes to infinity, so we want to say infinity. And we can put a bracket around the 4, a parenthesis around the infinity. Okay, letter B. What is our base graph? Basic shape here. Yeah, the slide. Very good. So this is y equals x cubed, or that slide function, because it's x to the 3rd power. All right. And so that had 3 dots on the diagonal. So those are my 3 dots we're going to start with. So 3 dots on the diagonal, 0, 0, 1, 1, and negative 1, negative 1. And it's this slide shape. It's mostly up, 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 a little bit over, and then up, 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 up. Okay, so don't make it too curvy. Don't go crazy. It's like up a lot. Slide a little up a lot. Okay. All right. And then we need to shift this graph. How is x plus 3 going to shift this graph? Left 3. Good. Left 3. And what's the minus 2 do? Down 2. So I'm just going to take 0, 0 and go left 1, 2, 3 and down 2. And then make my little diagonal points. Same shape. It goes up, 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 slide a little, and then up, 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 up. Don't go crazy with curves and make it all like groovy. Okay. Yeah, it's not psychedelic or anything like that. It's just pretty boring. Okay. What do these arrows mean? Infinity. They're going up a whole lot, but they're also moving out to the right, getting a little bit wider. So this arrow is moving down a whole lot, but it's also moving outward to the left as well. So it's going to go forever to the left and forever to the right. So the domain is negative to positive infinity. The range, how low does it go and how high does it go? Also infinity, negative infinity to positive infinity. Okay. Any questions so far? Is it easy, right? It's nice. It's fun. This is my favorite stuff. It's very fun. All right, last two. We have y equals x plus 1 quantity squared minus 3. All right, what is our little base graph here? Parabola, y equals x squared. That's our U shape, the parabola. We got those main 3 points. That's where we're going to start. So those 3 points were 0, 0, 1, 1, and negative 1, 1. And it's that parabola shape. Make sure your shape is nice and smooth and rounded. Really important that it's very different than the absolute value. And how is this parabola going to be shifted? Left 1, good. Left 1 and down 3, good. So I'm just going to take 0, 0 and slide left 1, down 3. Left 1, down 1, 2, 3. I had a really mean teacher for Algebra 2 when I was in high school, which made it really awkward when I came back and started student teaching back where I had school. So, and then a coworker retired a few years later, and he was at that retirement party, and he's like, I remember you. And I was like, yep, you were my Algebra 2 teacher. And he said, did I ruin your life too? Yeah. He used to sit at his desk in the front of the room and pass out tests alphabetically. And he'd be like, Amanda, you could have done better. I got a 99 on the test instead of 100. And then the guy behind me, I can't remember what his name was, but he was Middle Eastern and like the smartest kid ever. And he's like, even Amanda beat you. But he was awful. It was terrible. For every student, he had some horrible comment. Yeah. But he was really picky. I lost that point on that test that I got a 99 on because my parabola wasn't perfectly symmetrical. Oh. Yeah. Yeah. So know that I'm not that bad, but please make it nice and rounded. Okay. All right. Domain. How far left and how far right does this pink parabola go? How far left and right? Infinity. Thank you for not answering. No. Okay. Range. Range is the y-axis. How low and how high does the parabola go? What's our lowest y value? -3. Very good. Right here is our lowest y value, the very bottom of that parabola. So -3. What's our highest y value? Infinity. Thank you. Very good. Bracket, parenthesis. Okay. Last one. Y equals the square root of x minus 3 plus 4. What is the shape of this graph? The swoop. Y equals the square root of x is our swoop. Whoop, swoop. So that is our starting shape. Where do those swoop points land? 0, 0, 1, 1, 4, 2. 1, 2, 3, 4, up 2. So there's our starting swoop. Square root swoop. It really helps if you get the right, like, square root swoop. Like, do you hear it in my voice? Like, swoop. Do you hear it? Okay. All right. I know I'm just the craziest ever. How does x minus 3 shift to this function? Right 3, good, and up 4, very good. So right 1, 2, 3, up 1, 2, 3, and 4, and then I'm just gonna sort of sketch that same shape. This point right here is a terminal point. The function stops right there. Do not make your line longer. Do not put an arrow going out to the left. It stops right there. So make sure it terminates, okay? So domain. How far left and how far right does that pink function go? What is our farthest left x value? 3, right here, 3 on the x-axis. And it goes then forever to the right, so all the way to infinity. Bracket, parenthesis. Our range, what is our lowest y value? 4, right here, 4 is our lowest point on our pink curve. And it goes above that, so all the way to infinity. 4 to infinity, bracket, parenthesis. Okay, question 3.